Hi all, welcome to my channel AWS for all. Today I'm going to talk about AWS VPC service, Virtual Private Cloud. Virtual Private Cloud service facilitates user to create their own private network inside AWS infrastructure. AWS provides their infrastructure service in 36 different regions. These regions are nothing but physical geographical location across the world. In the below examples, you can see US East 1, North Virginia, Europe West 1, Ireland, AP South 1, Mumbai. The first two character indicates the geographical location. US means United States of America, East means the positions, East, West, North, South, and number 1 indicates the sequence number. Each region is subdivided into availability zones. Every availability zones will be hosting a few data centers. These data centers are the physical facilities which houses multiple services like memory service, networking service, and servers. All these availability zones are connected with a low latency network which facilitates fault tolerance architecture and also highly available and highly scalable architecture. For example, if any applications are running in availability zone A and availability zone, and availability zone is disconnected for any reason, that all the traffics will be served from the availability zone B. I try to map the US West 2 region with the diagram. This is how it looks like. US West 2, United States West 2 is the region. Every availability zones will be named suffixed with a letter here. US West 2A, US West 2B, US West 2C. Virtual private clouds are private network which user can define on one or more availability zones. In these examples, there is a virtual private cloud which is hosted on availability zone 1 and availability zone 2, and each zone is hosting subnets. Subnet is part of the virtual private network, and there are two types of subnets. One is a private subnet and another one is public subnets. The private subnets, the traffic is served within the virtual private cloud, and the public subnet, the traffic is served across the VPC, and also it connects to internet through the internet gateway. The subnet category is defined by the route tables which is attached to this subnet. In case of private subnets, the route table will not have any routes to internet gateway. In case of public subnets, the route table will have a route associated with the internet gateway. Any IPs which is trying to reach external world, it will be routed through internet gateway and it goes to internet. These CIDR blocks are blocks of IPs which are used to define VPC boundaries. I have taken an example to define a VPC CIDR block 10.0.0.0/16. This is a VPC CIDR block and these are all the decimal numbers, and we are going to divide this into 4 subnets. There are 4 steps. These are technical mathematical steps. Step 1, analyze the requirement and calculate the available CIDR block IPs. So for this 10.0.0.0 means the first 16 bytes are constant, and remaining 16 bytes are used to distribute these IPs across the VPs. In this example, the usable IPs are around 65,534 IPs. In the step 2, I divided this into four chunks. That is nothing but 16,000 383 IPs for each subnet, and when I calculate it with the binary, it is coming up to 2 raised to the power of 14. What it means, in 14 bytes are enough to define an subnet. In the step 3, assign the subnets to the availability zones, which availability zones it should be, and consider unused IPs. There are few IPs which are used by the AWS services itself. For example, network address 10.0.0.0, it's reserved. First usable IP 10.0.0.1, last usable IP 10.0.63.254, and broadcast address 10.0.63.255. This diagram shows the mapping of VPC CIDR blocks which we have taken. 10.0.0.0/16. Here the first 16 byte is constant and the last 16 bytes are used to define all the IPs. The IPs are ranging from 10.0.0.0 to 10.0.255.255. When I map this into the binary, this looks like this. First two octets are constant, the one which is marked in red, and the second two octets which are marked in green are variables. As per our calculations, the 14 bytes are good enough to distribute the 16,383 IPs. So I kept the last 14 bytes as a variable and first wait 18 bytes as fixed for the subnet 1, and it starts with 0, 10.0.0, 10.0.63.255 is the last IP. This covers 16,383 IPs. Similarly, I have divided the second subnet. In this one, if you observe, the third octet first two bytes is 01, and remaining 14 bytes are variables. So again, this will range from 10.0.64.0 to 10.0.127.255. Similarly, I have subdivided the subnet into another two chunks, starting from 128 to 191, and the last one from 192 to 255. Available CIDR blocks IPs are equally divided into 4 subnets here. I try to map the CIDR blocks and the IPs into the actual VPC diagram. Earlier we saw the region, subnet, VPC, public subnet, private subnet, and divided into 2 availability zones. This is how it looks like when I map the previous IP address or CIDR blocks. The virtual private cloud VPC 10.0.0.0/16, ranging from 10.0.0.0 to 10.0.255.255. Here 10.0, the first two octets are constant, and the first availability zone I have defined the public subnet 1, and in the same availability zone I have defined the private subnet zone, subnet. Similarly, in the second availability zone I have defined the third subnet, that is a public subnet, and the fourth subnet is in the private subnet. I will show in the demo how to map the route tables into the internet gateway and how to avoid the internet gateway traffic for the private subnet. Let's go to the demo. We'll create this VPC with the CIDR block 10.0.0.16, and we'll create the 2 subnets in the availability zone 1, and in availability zone 2 we'll create 2 subnets, one public and one private, one public and one private. Let's go to console. In this console, make sure you are in the right region. At the top right corner, You can see the region which you are pointing to. Currently we are creating the VPCs in the US East 1 region. Click on this and type VPC in the search bar. Currently there are no VPCs available in these regions. We are going to create a new one. Right at the top right corner, create VPC. In the create VPC sections, there are two options. One is VPC only and other one is VPC and more. In VPC only, we had to create every component separately. However, in the VPC and more, all components which are required for the VPC, that is including subnets, route table, internet gateway, everything will get created in the package. So let's try with the VPC and more. And the project name is auto generated and we are going to change it demo VPC. And the setup block is already selected 10.0.0.0 and 16 range, and you can see the number of IPs available here. 65,536 IPs available in this VPC setup block. Tenancy is a default tenancy, and at the bottom it's asking a number of availability zones in this VPC. We are going to select 2 availability zones, and if you expand this drop down, it will ask for the availability zones. As we discussed earlier, we are going to create in US East 1A and US East 1B, US East 1A and US East 1B. Move on to the next one. The number of public subnets we needed 2, and a number of private subnets we need 2. So we can click on the customize setup block. By clicking on the drop down, we can customize our subnet setup blocks. Here by default it will be 20, but we are going to change it as per our diagram. Let's go back to our diagram. The public subnet 1 in availability zone, it's a 10.0.0.18. Let's make the change. It's a public subnet setup block in the US East 1 10.0.0.18. The next one, we are going to define public subnet setup block in the US East B. Public subnet in US East 1B, it's 10.0.128.0. Let's make the changes. .128.0 and /18, and now we are going to define the private subnet setup blocks in the East 1A. The private subnet 01 starts from 10.0.64.0. The private subnet starts from 64.0, and the second private subnet in the US 1B, we need to change this. The private subnet 02 ranges from 10.0.192.0 192.0/18. So we have customized the IPs for the subnets, and come down, and the NAT gateways, as of now we are not creating any NAT gateways, and also we are not going to create any VPC endpoints. Enable the DNS host names and enable the DNS resolutions, and click on create VPC. You can monitor the VPC creations here in the details, and just wait for a minute and VPCs will get created. Now it is successfully completed all these activities. Create VPC, enable DNS hostname, and create root, associate table, root table, associate root table, and it completed all the activities which was planned. And we can go ahead and check each one of them. View VPC. This is a new VPC it got created. So demo VPC, and if we go and click on the CIDR block, it will show the CIDR blocks which we have created. It's 10.0.0.0/60, and if you go to the subnets, we can see the 4 subnets which got created in 1A, 1A, 1B, 1B, and in the VPC there is an option to see the actual flow. In the resource map, it shows the actual VPC and subnet relations. This is easy to understand. Demo VPC is the VPC which we have created. In this one, in the East 1A, there is a demo VPC subnet, public subnet, demo VPC subnet, private subnet, demo VPC subnet public 2, demo VPC subnet private 2. So in East 1A, one public and one private subnet got created. In East 1B, one public and one private subnet got created. As we discussed earlier, the public subnets will be having the root tables. This root table is a demo VPC root table public, which will be get connected to the demo VPC IGW. This IGW is nothing but a internet gateway. All the traffics coming from external to VPC will handle through this IGW. In case of private subnets, so it's not tagged with any IGW, that is internet gateway. All the traffics there's no traffic going out of this private network, and it will be within the VPC. We'll go ahead and see all these components one by one. So click on this public subnet, or we can go to the public subnet here. Click on public subnets. Demo public US 1. Let's go to the public subnet US East 1A and click on the subnet, and you can check the details here. Subnet ID, and it comes with the CIDR block. This is a CIDR block which we defined, and the subnet comes with an ARN and available IP addresses. You can see it here, and availability zone ID. If you come down at the bottom, so the root table, this is the important thing we need to check. Since it's a public subnet, there are 2 roots associated with it. The root table, actual root table is this one, the RTB, and ends with 35AA. So here there are 2 roots as defined. 10.0.0.0/16 and local. This means like any traffic within this VPC. This is a VPC CIDR block. Any traffic within this VPC CIDR blocks will be local, and it will not go out of this VPC. However, any traffic serving in any IP 0.0.0.0, that means any traffic which is going outside the VPC will be routed to IGW. This is nothing but internet gateway. You can click and check the internet gateway here. It got created demo VPC IGW internet gateway. The internet gateway will be associated with the VPC, and there will be one internet gateway for VPC. Let's go back to the VPC and click on subnet. We check the public subnet, and similarly the other public subnet will be having the same setup. Let's check the private subnet. Click on the private 1 US East 1A. Click on the private subnet. It will show the CIDR block range and number of IPs available, a route table associated with, and the actual routes. Let's go to a route table. In this case, all the traffic which is generating out of 10.0.0.16 will reside within the local. In this exercise, it also created a VPC endpoint, and all the routes listed in this list, a PL list, will be routed to VPC endpoint. However, it's not required for our use case. So all these VPC and subnets are created successfully. In the next session, we'll try to create the EC2s inside this private and public subnets and try to connect each other. Thanks for watching. Please subscribe and like.